explain. I will explain more about this. And the last one is the ground bearing pressure. I think you all have familiar about this term. So the ground bearing pressure is a stress on the ground that caused by pressure from the crane itself. Now we go to the crane COG stability. Uh, as I have mentioned before, crane COG is calculated by combining the crane's component and the load itself during operation. So for the crane's load, we will use the load to lift, which has been explained yesterday. So load to lift consists of the gross weight, rigging weight, and hook and reeving weight. Sometimes we also includes the dynamic factor to the calculation, so it will give more contingency to us. But in some condition, for example, if we use a suspended superlift counterweight, the load will be no longer realistic and lead us to unrealistic superlift requirement. And if we use an unrealistic superlift, maybe during operation it will be okay. But if it happens many times, it could damage the track of the crane or the superlift connection. So we back again, and for the cranes that load, you should refer to the cranes manufacturer. Usually they provide all the information about the components like boom, hook, counterweight, tracks, and any other things when we purchase the crane. And it will be better if we could get the COG from them as well. Otherwise, we need to justify or estimate where the COG of each components located. For example, here just to showing what exactly I meant about how to calculate the COG. So in this picture, it is showing a crane with a complete component like boom, the lattice boom here, tracks here, counterweight here, car body mast, the car body here, mast, and the others. I will use the center slew bearing or the center of the turntable as our origin point here. So this is X and this is Z axis. From that, we can measure the distance from components from the component COG to the origin point. So for example, this crane boom will if we want to get the COG of in X axis, then it will be, for example, the crane boom weight times the distance of the COG from the COG of the crane booms to the center of the origin point, which is the center of the slew bearing, which is L3 here, and then we plus load to lift times L4. So all will be measured from the to the center of origin point, and then the mass times L1 plus counterweight times L2. And if you have another components, you can add in here and then divide it by the total weight or total load. That's how we got the COG on in X-axis. If we want to do the if we want to know the COG on z-axis, then we we need to know where is the distance we use here, L3, L4, L1, and L2 will be on the z-axis. So for example, for the counterweight, let's say it will be here, then it will, let's say it's L no Z2. For the crane boom, let's say it's Z3. And for the load to lift, it depends on the load COG also. Let's say the load is here, then the COG is here, and then it will be uh Z4, like that. And then we will use the same formula to get the COG Z, crane boom times Z3 plus load to lift times Z4, and so on and so on, divided by the total weight, like that. And that's for the X for the elevation view. If we it is important also to get the COG on plan view here. Let's say the boom is toward to this way, then we will use COGY. We will use the same formula, but the we will in the calculation we use the distance through y-axis here. Once we get the combined COG, then we can calculate the ground bearing pressure and the tilting angle. So yeah, that's how to get the crane's COG during the operation. And don't forget to uh, put the load to lift into the calculation, because that's important. So yeah, so that's COG of the crane. So this is the one we have talked about yesterday, which is showing how the load and slewing in certain angles can impact to the ground bearing pressure. As I've mentioned yesterday, the COG of crane usually in line with the boom direction. So so when there is a slewing at the boom to this way, for example, the COG will be moved at the same line as the boom direction. It can be here, here. It depends on the which load is dominant. Either it's the load to lift on here, or the counterweight at the behind. And then the tracks where is close to the COG will get the biggest pressure. If there is no load at the hook, then the COG only affected by the counterweight. And for sure, the COG will be at the behind the crane's center. And if the COG at the behind, then for sure the track at the behind will get the biggest pressure than at front. But when the load is attached to the hook, the COG will move to the front, and then the biggest pressure now is at the front. it is same like seesaw, if you know. So it's about balance between the front and the rear load. And it will be the same situation with crane with the outrigger here. The difference is how the mechanism to distribute the total weight to the foundation. In this case is it's the outrigger itself uh, based on the COG location. If the COG at the front of the crane center, then the most pressure will be at the front outriggers. And if the COG at the back, then the most pressure will be at the back of the cranes. So now we will talk about tipping line and tipping angle. For a crane with outriggers, the tipping line are lines which connected all the outriggers point like this. And if the crane is working with the tire also, then we will have a additional tipping line to connect the tire point as well. So it will be like this. As long as the COG inside the tipping line, then the crane should be safe during lifting. If the COG out from the tipping line, then we should rearrange to make it inside. So yeah, that's for the crane with outrigger. And the next one is crane with track or crawler. There are two types of track we see here. One is track with non-elevated sprocket. For this type, the longitudinal tipping line will be drawn from center of its sprocket here. And the other one is the elevated sprocket. And for this type, the longitudinal tipping line will be drawn from the edge of the track, which are touching to the ground here. And for the transversal tipping line, we could take it based on the center to center of the tracks here. Is there any question up until this?
Do you have any question, everyone? If you have any question, you just raise your hands and then feel free to ask. So far, so good, yeah?
Yes,
Yeah,
Mr.
go
Nil,
ahead, Sarma.
this is Sharma.
Yeah.
If it has been a elevated sprocket, where you will be
Yeah.
drawing the tipping line?
So it will be from the center of the sprocket, not elevated, yeah. From for the elevated, you can draw it from uh the edge of the tracks which are touching to the ground.
Okay.
Yeah, yeah.
And if it is non-elevated, then it will be from the center of the sprocket.
Correct. Yes.
Okay. Thank you.
Yeah. Okay. Now we continue with the tipping angle. Tipping angle is an angle that measure from the COG to the closest tipping point. For example, if we want to calculate the tipping angle for crane that using tire as the foundation as shown here, if the COG located close to the front tipping point, uh, sorry. So if the COG located close to the front tipping point, this is the tipping point here. and the COG close to the front tipping point, then we will measure the tipping angle relative to this tipping point. But if it's the COG that we have calculated close to the rear tipping point, let's say here, then it will be measured from the rear tipping point here. So the tipping angle will be this, like that. So we could simply, by using tangent of horizontal distance divided by, so this is the horizontal distance divided by the vertical distance here, x, z. So it will be our cosangent yeah across tangent a x per z, like that. So yeah, but yeah, so that's for crane with the tire, and that's for the longitudinal section. Beside the longitudinal section, we also have to check with the transversal section. We will measure the tipping angle according to where the COG located and which tipping point is closest to the COG. Same process with the as the longitudinal section, like that. And the next one is the crawler crane. Same concept we will use here. The tipping angle to be calculated according to where the COG located. If the COG close to the front tipping point, then we calculated the tipping angle based on the distance of the COG to the front tipping point, and so on. If the COG close to rear tipping point, and you need to be careful about the crawler's type. If it's non-elevated or elevated sprocket, and this one for the tracks with elevated sprocket. We will use the tipping point at the edge of the where the tracks touching to the ground here. Beside the longitudinal section, don't forget to check the transversal also. Here, actually, it is mentioned that the tipping line of transversal section is at the outer connection between the tracks to the car body, but we could just use the center to simplify the process of calculation, since it's more conservative. Now, the question is, if the COG higher, will it be safer or not during the lifting? Let's say the COG is somewhere here. Will it be safer for the lifting or not? So
No,
I think,
it is not
yeah,
safe. It will
yeah,
face
yeah,
the lateral stability, then the crane will tip on the right hand
yes,
side.
correct, yeah. So the answer is it's not safe. Now the next question is, what are things that could make the COG become more higher during the lifting operation? Then the answer is the load itself. So if we put the load, the higher the load we put in the lifting, then it will make the this COG higher than uh, the allowable. Then it will impact to the tipping angle become smaller, and it will causing potentially causing the tipping during the lifting operation. So practically saying that the tilting uh, is will the tilting on the part line of the crane will create another additional moment to the crane's equilibrium also. That's why if you know the that's why we never allowed to have crane configuration, not crane configuration. We never allowed to having a tilting uh, on the load during lifting, because this potentially could pull the COG higher than the our calculated. There will be another additional loads here at the boom tip that potentially this COG will become more higher. So yeah, uh that's for the tipping. uh So once we have calculated the tipping angle, then we now could check the requirement. What is the minimum tipping angle that a load based on the condition during operation? So for this case, I'm referring to ISO 4305 2014. There are various minimum requirement of tipping angle shown in this table. For example, if you want to do the lifting with a crawler crane and it will be traveling, you can use minimum tipping angle 5 degree here, and it also depends on the traveling speed. But if it's only slewing or rotating, then you can choose minimum tipping angle 4 degrees here. That's showing to us that the bigger tilting angle will be more critical the the than the smaller one. So is there any question up until here? If no question, let's now we continue with the ground bearing pressure. Before we start into this, I'm gonna put some disclaimer here uh, to always use the software that has been approved by manufacturer to calculate the ground bearing pressure, because they know their things and what is inside the crane. So for your own safety, I will recommend you to follow the manufacturer's ground bearing calculation. The one that we want to share here about ground bearing pressure is the basic how this things work. So that when you get into the software, it will be easier for you to understand and no input error. So it could lead you to the better result. Here I put links in this table that contains a ground bearing pressure from center manufacturers. Some of them are free, like Tadano, uh, Kobelco maybe, and most of them you need to buy the crane to get the software. But for preliminary study, maybe you could calculate it manually before get into the detail. The first example is crane with outrigger. The sample I took from another class, WIG and COG calculation class. So let's say we have a mobile crane with outrigger here, and we have configure weight and COG of each item in the table, like the load itself, boom, car body, and counterweight. Now we are going to find the ground bearing pressure of this crane during lifting. And also we have the coordinates of each item here. Since we are only need to find the ground bearing pressure, then we only need the X and Y coordinates. For Z coordinate, we will use that for stability, like calculating the tilting angle like that. So first we need to find the total weight and the COG. For the total weight, we can just simply sum up all the item. Then we got the total weight is 1,625 kilonewton for the total weight. And then we calculate the COG by using this formula as I have explained before. So, however, this formula is common we use in calculate COG for a structure, and I think we have already got this from high school. Yeah. So if we want to calculate the COG in X direction, then we input the weight of each items and multiply them with the X coordinate of each items here. So here we got the COG at x-axis is about 5.35 meter. And if we want to get the COG in Y, then we input the weight of each items and multiply them with the Y coordinates here. And then we got the COG at Y-axis is about 5.28 meters. And if you want to get the COG in Z direction, you can use COG Z coordinates in the formula here. But in this case, we will not use that to calculate the ground bearing pressure. So that's how to use this formula. But don't forget, you need to consistent to use the origin point. So all your COGs should be measured from the origin point that you have decided at the beginning. You are free to choose wherever you're gonna put the origin point as long as you consistent with using that in your calculation. So for this case, I put the origin point here because that time I used this crane for lifting on the Jacob bar. So I need to check where is the COG and the outriggers forces during lifting and give this information to another parties to check the bars itself. So that's why I put the origin point on here to follow the center of the origin of the bars. However, I prefer to for the next case, for crane check, I prefer to put the center of Sembiring as my origin point here. Yeah. Just to avoid confusion during the calculation. So now we plot the COG like here. It's 5.35 meters x COG, and it is measured from the origin point. So the distance to outrigger A is 3.82 meters. And the YCOG is 5.28 meters. And the distance to A is same because the origin point I use exactly at the point A for the Y axis here. Just for information here, the boom slewing angle shown in this picture is indicative only. So you might see that the COG here is not in line with the boom. That's because in this job, I actually check the COG in each degrees of slewing angle. But in the drawing, it is shown on only one slewing angle, just to avoid confusion. And then I copied this picture from the actual drawing. So yeah, there is the COG. Now we try to find out the reaction of each outriggers. I'm assuming that this crane is rigid, meaning to say that the flexion of outrigger's frame will be ignored in this calculation. So that we could calculate this by using determine static structure analysis. First, we will distribute the load to one pair of sides. You can choose either it's to the left or to the right or to the top here DC and to the bottom. So for this case, I choose to distribute it to the left and right. So to the left, to the right. So it will be, if I look at this side, then it will be, there will be AD at the left and BC at the right, and the load will be sitting on here 3.82 from AD, 3.82 and 5.44 from BC. So now we can simplify the system by become a determined static structure. Now we calculate the reaction at point AG. Then we use total moment at BC is 0. So what are the moment at BC? There will be RAD times 9.26 meters, the distance to BC, minus P total. This is total weight that we have calculated before, times 5.44, the distance to BC, and we get the reaction at AD is 54.64 kilonewton. This is a combined reaction between outrigger A and outrigger D. And to calculate the reaction at BC, then we will use the sigma moment at AD equals 0. And same process, we get the air reaction at BC is 670.36 kilonewton. And then we do the equilibrium check by total forces that equals 0. And we got 0. That means the our reaction are already correct and we are in the equilibrium state. So that's the combined reaction between AD and BC. Now we distribute the reaction again by using the combined reaction. Like for example, for combined reaction AD, we will distribute to the A and D. So if we look at back to this drawing, after we distribute from the COG, then now we will distribute to the A and D, and the reaction BC we will distribute to C and B. So if I look to this way, then there will be A at the left, D at the right, and the load is coming from the combined reaction AD, which is the distance from A is 5.28, like that. So this will be 3 point what is this, 3.1 1 2. So yeah, and then we could calculate the reaction at AD by using the combined reaction RAD that we have calculated. We get 954.64 kilonewton. To calculate the reaction at A, use the total moment at D equals 0, and then we get the reaction at A is 347.35 kilonewton. And for the D, we use a total moment at A equals 0, then we get the reaction at D 607.29 kilonewton, and then we do to check the balance or equilibrium, like that. And then we will do the same to get the reaction at B and C by using the combined reaction B and C 670.36 kilonewton that we have calculated. And to get the total moment the reaction at point B, then we use total moment at C equals 0. Then we get the RB is 243.91. And so with the reaction at C, then after that we do the equilibrium check. Or to simplify the calculation, for example, for this we could calculate like this. To get the RB, then we will use the 3.2. We will use, let's say, this L1, L2, and this is the total length is L. Then RB is L2 divided by L times the RBC, the total load. And then for the RC is L1 divided by L times RBC. It will be the same result. So now once we got the outrigger forces, now we could check the ground bearing pressure. It will be simply by using formula force divided by bearing area. Now, in this case, the size of the outrigger is 0.6 by 0.6 here. And we put 100 millimeters thick of bearing pad underneath. This is the outrigger, and this is the bearing pad. It's 100 millimeters. So first, we need to find the effective bearing area. The mechanism of load distribution is like this. The outrigger force will be distributed to the bearing pad, and then the bearing pad will continue the pressure to the ground with a certain angle. So the effective area at the contact between bearing pad and the ground will become more bigger. It depends on the material of bearing pad and the thickness that we use. So it doesn't matter if you have a bearing pad as wide as a football field. If the thickness is only 1 millimeter, then it will be no effect to the bearing pressure to the ground. So as we can see in the table, I assume the bearing pad bearing pad material in three different materials, and if we compare three of them, the bigger area belongs to the concrete here. So concrete is good in load distribution, especially for bearing, but it is less flexibility because it's weight. So to get the effective area here, we need to calculate the width effective and the length effective, and this width and length effective we get based on this. So for the steel, I get we have the B is the outrigger width. The original outrigger is 0.6 time 0.6 by 0.6, 0.6 width, 0.6 length. So if it's a B plus 2 times the thickness is 0.1 meters, then it will be 0.8 for the width effective and 0.8 for the length effective. To get the effective area, we just multiply them. Then we got the for the steel 0.64, and then for the wood it will be more bigger effective area, B plus 3 times of the thickness of the bearing pad. So we get the effective area is 0.81, and for the concrete is 3.24. So from the previous calculation, we get the maximum load is 607.29. So the ground bearing pressure will be simply by using the formula P divided by the area, which is the P is the maximum. I use the maximum load. If you want to check all the outriggers, then you must use the specific load for each outriggers. So this is the maximum load, 607.29. Then the ground bearing pressure for this, I got if we use the bearing pad from steel, then we got ground bearing pressure 949 kilonewton per meter square. If it's wood, then it's 750, and for the concrete, it's 187. So the concrete is more better than the other materials to distribute the pressure. So yeah, that's for the outrigger. Any question for the outrigger's ground bearing pressure?
Yeah, do you have any question, everyone? Maybe from Sarma or from Paul or from Kevin and Aviv? Mohammed, do you have any question?
No questions or question, Dian and Nelson. Thank you.
Thank you so much,
Thanks,
Paul.
Paul.
Sarma, you are
Yeah,
unmute now. Do you have any question?
yeah, no questions. Thank you. But I had a concern like steel, wood, concrete, whether
Yeah.
the material is going to affect the ground bearing pressure. Because see, the thing is like it depends on the area. That is
Yeah.
what we have to concentrate, right? Because if you see the maximum load is 607.29, And
Yeah.
the what is the area it is going to be pressure is, that is the one 607.29 kN, and you are
Yeah.
going to take it with the area. If the concrete you are been going to use it 1.8 into 1.8 meter
Yeah.
by the concrete, then it's going to be 3.24. The same way, if I'm going to use the steel mat for 1.8 into 1.8, then for sure it's going to give for the same ground bearing pressure, right?
Yes,
Because
but
the area
the
is going to be 3.24.
yeah, but the you need to check the steel mat itself. Uh, if it's because there will be a bending or punching in the on the
Correct, sir.
steel
That is
mat.
what we are
The
going to use the thickness.
yes, yes.
Yeah, that's what to avoid that punching only we are going to use the thick, right?
Yeah, if it's there is a bending on the plate, then it will be not normal pressure anymore. So you need to consider the bending of the mat itself.
Mm,
Yeah.
okay, thank you.
Yes, no problem. If no question, the next one we continue with the crawler crane here. So for this type of crane, there are three types of ground bearing pressure that could be considered. First is ground bearing pressure due to the normal pressure. Uh, the second is ground bearing pressure due to moment forces on x-axis. And the third is ground bearing pressure due to the moment forces on y-axis. To get these three things, we need to know the COG of the crane, and the calculation process is same as previous crane without triggers. We need to combine all the components, weight and COG plus the load to lift. If the COG has offset to the x-axis and y-axis, then there will be moment forces appear on each axis, and the moment forces will give additional pressure to each tracks. Now, for example, we have a crane COG as shown in this red dot, and it has offset to y-axis 2 meters, and to x-axis is 1 meter. The total weight of crane and load to lift is 218.3 tons. And we need to calculate the ground bearing pressure. First, we will calculate the ground bearing pressure due to the normal pressure here. For this, we could simply just divide the total load with total area of the tracks here, which is in this case 1.2 times 1.2 times 8.1 and times 2, because we have two tracks. Then we got the total area for the tracks is 19.44 square meter. Then we divide the total load by the area. We got 11.23 ton per square meter for the normal ground bearing pressure. And the next one is ground bearing pressure due to the moment on x-axis. As we know, the formula to calculate moment force is load times the offset measure from the origin axis. So if we want to calculate moment x, then we use the uh, uh, offset in y here. Yeah, this one. So because this offset will cause the crane rotating in x direction like that. So for the moment, we got 218.3 times 1 meter. It is 218.3 3 tons meter. Now, how we distribute this moment to the tracks? That's the question. We will use section modulus of the track to calculate to distribute the moment to the track. Now, what is the section of modulus? So it is a geometric property of section. In structural engineering, we use this to design a flexural member like a beam or even pedi. So basically, this calculation is same as if you want to design a pedi. The formula you can find in structural engineering books. So first you need to find the inertia of the tracks here. You can just use this formula if because it will be same for all will be same tracks for the other crane. So but you need to adjust what is the B and the H here. And then once we got the moment of inertia of the tracks for x-axis, then you can calculate the section modulus by divide the inertia by distance of center of the tracks to the center of axis. But yeah, so let's say the distance here from the center point of the track to this to the x-axis is here. So if it's the center of the tracks, then the distance that we use to calculate the section modulus will be this. So in this case, we get the moment of inertia is 352.3 meters rank 4. Then we divide it by 4.25. 4.25 I get from this. It will be 7.3 divided by 2 plus 1.2 divided by 2. Because it's the distance between the tracks is 7.3, then to get this, we will use this formula. So we got 4.25 for the distance, and then for the section modulus on the x-axis, we get 82.9 cube meter. Then the ground bearing pressure, we could calculate by divide the moment on x-axis divided by the section modulus itself. So 218.3 tons divided by 82.9. So we got the ground bearing pressure is 2.63 tons per meter square. Now for the ground bearing pressure due to moment on y-axis, it will be the same as previously. For the moment on y-axis, we get for the moment on y-axis, what the distance to make this rotating on y-axis is this 2 meters. So moment y-axis is 218.3 times 2 meters. So this is the moment on y-axis. So for the moment y-axis, we get it's 436.6 ton meters. And for the moment of inertia, we will use this formula and we get 106.3 meters rank fourth. And for the section modulus, the moment of inertia will be divided by distance from the end of the track to the y-axis. So it will be this. and it will be 8.1 divided by 2. Then we get the distance is 4.05, and the inertia is 106.3 divided by 4.05. We get the section modulus on y-axis is 26.2 cube meter. Then to get the ground bearing pressure, then we use this formula, moment y-axis divided by section modulus on y-axis. We get 16.7 ton per square meter. Now we need to, after we get all these three items or three things that impact to the ground bearing pressure, then now we can combine all of them together. So to combine this together, then we need to know where is the COG location. So because the COG location is here, which is it's on the X positive and Y positive, then this track will get all, we will add all the ground bearing pressure to get the total pressure. So for example, the ground bearing pressure 1 is the normal ground bearing pressure, and then we use plus ground bearing pressure 2. This is because of due to the moment X, and then plus ground bearing pressure, that's due to ground bearing pressure due to moment on y-axis. And for this track because it's rotating, because the COG intended to make the cranes rotating to this side, then the moment the ground bearing pressure due to moment y, which is the ground bearing pressure, we will use negative here. So the formula will be ground bearing pressure 1 plus ground bearing pressure 2 minus ground bearing pressure 3, like that. Why the ground bearing pressure 2 positive? Because the ground because this crane will be rotating to this way, then it will put more pressure to this side of track, like that. So because of this moment X rotating to this way, it will add more ground bearing pressure to this track and this track. So that's why we put ground bearing pressure 2 as a positive here at this side, and the ground bearing pressure 2 as a minus on this side. And for the ground bearing pressure 3, because this moment Y make the crane rotating to this way, then it will give more pressure on this side of tracks. So that's why we use the plus ground bearing pressure 3 on this, and minus ground bearing pressure 3 on this side. And then we total them together. For front ground bearing pressure, we get 30.56 ton per square meter. This is the left and the right. For the left track, we get 30.56 ton per square meter at the front, and 2.84 at the minus 2.84 at the rear. And for the right track, we get the 25.3 at the front and minus 8.1 ton per square meter at the rear. Now the question is how this ground bearing pressure, if it's negative pressure to be distributed to the ground. So in this picture, I put that negative as a 0. That's because when it's actually there is no negative pressure in reality. That's why I put as a 0, because it will start to losing the pressure at the rear, and I think it will be started to be tilting as well for the crane during the lifting. So that's why I put the 0 at the back. But for the good uh when when we so the good design on the lifting, it's we should put have a positive ground bearing pressure or at the whole of the track. So this is what we have here as example is not a good lifting plan for us to be followed. So I just want to show you what's not what is not good or not to follow for you the next in the next uh lifting plan. So yeah. So yeah, I think that's all for the ground bearing pressure. Is there anything that you want to ask or need to clarify from this part?
Yeah. Do you have any question, everyone? Yes, Paul, do you have any question? Go ahead.
Thank you, Dian and Nelson. I just want to ask, what if we don't know the ground bearing capacity or ground bearing pressure of I mean, the location, I mean, like soil or asphalt pavement, something like that. So how we can able to identify?
Uh, we could simply just hire the soil testing. Yeah. So we need to identify that before we doing any lifting plan for that. So yeah, just hire the expert to do the job
Yeah.
for that. Yeah, yeah. So I think that could answer your question, Paul.
Yeah, thank you so much, Nelson, because this is the most, I mean, one of the most interesting discussions that we had a couple of months ago.
Uh-huh.
Because we don't know the ground bearing capacity of the soil, and there's a healthy discussions back and forth, and then nobody can, confirm
Uh,
what is the yeah. So
yeah,
I
yeah.
recommended them to to consult with same what you have advised to us right now,
Mm.
to conduct a soil test, but until now, no, positive feedback from the operations team. Yeah. Thank
Yeah,
you so much,
yeah.
Nelson.
No,
Thank you.
sure, Paul. Yeah, that's a critical one before we doing any lifting plan. We need to know how the ground bearing pressure, so we could design as per the capacity. So yeah, any other question?
Yeah, Edmund, I just wanna add some information for you, like what Nelson said before. If you get geotech people to involve with your heavy lifting operation to identify about your soil, so you will get like a soil type, what if soil type for your operation, and also like if there is like a groundwater deep for your soil, and bearing capacity also, strength for your soil. So I think that yeah, it will be different. Like heavy lifting engineering is only focused for the crane itself, and then geotech people, which is the same, come from civil engineering also, but the different specialization. And geotech people will provide detailed information for you about your soil condition. So it will be correlate together, yeah, between your crane and also your soil, because like if you have operation on shore, so critical point is your soil, right? Your soil support. And if your operation in offshore, so critical point will be wave, listen trim for the vessel, like this. So I encourage your team to contact geotech people to provide a detailed report for your operation, especially if you have a heavy lifting operation, like this. Yes, Paul.
I have a second question, if I may, if you allow me. Sorry to ask a lot of questions right now. Is that okay?
Yeah, it's
Dian,
okay.
thank you so much. Second question would be, is there any specific technical specifications or requirement, international standards related to what the size of the trigger pad? Because based on my past experience, for more than 10 years, normally we are recommending the operations team, constructions team, at least three times of the size of the outrigger float. So now my question was there any technical standards that it says that minimum requirement should be at least three times the size of the outrigger float?
Uh, from engineering point of view, there is no correlation between the size, width, and length to the mechanism how the load will be distributed. As I mentioned before, it's about the thickness and what is the property uh, of the bearing pad. So, but I ever heard about that before, about what is the minimum requirement for that. If it, but I can remember, but I will try to find that for you, and will send you after this class.
Thank you so much, Nelson. Thank you.
Sure, Paul.
I also agree with Nelson. I think that there is no specification, like really like a specification. I think that crane bearing pad specification is depend on load capacity, and also like Nelson said before, like material requirement, pad thickness, and also pad area, yeah, or surface size, yeah, surface size. And also I think that also about your soil condition. So I think that there is no like a exactly size for your crane bearing pad. I never listen also like that. Just to be sure, it depend on load capacity, material requirement, pad thickness, surface size for your area, your soil condition, what surface features, yeah, it also this. So I think that the only that, like material requirement, of course, is like composite pads or not, plywood or not, and also load capacity. Also, this is really important for your crane bearing pad thickness. I think that you have to consider all of that. It's kind of like that, right, Nelson? It's not really like a specific, like how many size, right?
I believe there is one requirement about that, but
Mhm.
I will try to find that. By referring to engineering point of view,
Mhm.
uh, it's about the thickness and the
Material,
material of the
material,
bearing
yeah.
pad. That's how
Mm,
the load will be distributed
mm,
as a ground bearing pressure. But I will try to find that.
We will try to find for you.
Yeah.
We will try to find for you.
Thank you. Thank you,
Yes, for
Dian.
example, maybe like a minimum criteria or general specification, right? But you cannot use this. You have to also calculate what Nelson said before.
Yeah, thank you.
Yeah, you are welcome, Paul. So any question? Any other question from Sarma maybe, or from Kevin, or from Muhammad? Afif, do you have any question?
No questions. Thank you.
No
No
question.
questions.
So far,
No
so
question.
good, yeah? I'm okay.
Yes.
Okay, Kevin, thank you
Yeah,
so much.
you will be sending the video recording, right? Because I missed some
Yes.
portion.
Yes,
Yeah.
yes. I will send you video recording, because also our participant from Australia cannot join with us since now they are asleep. They are sleeping right now. So I will send it recording to all of us. So if you don't have any questions, so maybe Nelson, you can continue our class.
Okay, so the topic's already finished, so I will continue with the
Capstone project, yeah?
capstone project. This, as I mentioned before, that this capstone project is a real project, and no need to be perfect, but we are trying to build two-way communication between us and the participant, so that we know not to say to teach, but more discussion, open discussion with the participants. So yeah, this is the project we have.
So Nelson, sorry to disturb you. I think that we have to explain a little bit about our capstone, because Kevin just joined today. He's not joined yesterday. So Kevin, I would like to explain to you about our capstone. Capstone project is like a mini project that we give it to all of our participants at the end of our upskilling program. So the purpose for the capstone is to encourage people to read again or listen again our recording. And then the capstone project is based on real case study. So the capstone project based on our case study, and then no need to be perfect. You just try to finish your capstone, and then you submit to us, and then we will try to check your capstone. And if there is something wrong, we will give it back to you with advice or feedback. But if you did correctly and then perfect, so we will give it to you certificate of achievement. So the capstone project duration is for 1 month. So we hope that in 1 month you can finish your capstone, and then we will issue your certificate. But if you decide like, oh, I don't have time, so I'm okay, I don't need to finish my capstone, we will give you certificate, but only certificate of attendance. And why is different? Because certificate of achievement, we will attach your capstone at your certificate. So and if you don't have any capstone, so we cannot attach your capstone in your certificate, and it will be different from other participants. So we'll decide to give it to you certificate of attendance. So this is a short information about our capstone. And then you can send it directly to Nelson for your capstone project. So for people who already take several class with us, I know that you have several capstone already, and then you can simply ask to Nelson to extend your schedule, so you can have a lot of time to finish your capstone. So Kevin, this is short information for you. Thank you so much, Kevin. I know that you are still working, right? Because now 11 o'clock US time here in my time zone. So if you have any question, you can text me, or you can call me, or you can directly text to Nelson. Thank you so much, Kevin. You can go ahead, Nelson.
Just to add here, this is not about right or wrong, but this is more like two-way communication between us. So yeah, there is no right, there is no wrong in the engineering. Just what codes will be used for this design, right? So for this capstone, we have gas turbine here, and we will doing offloading from the vessel uh, to the yard here, and the weight of this is 241 tons here, and the dimension also mentioned here. For the crane, you can choose by your own what crane you will be used for this arrangement. But if you don't have one, then you can text me or communicate to me, so I will provide one crane that you can be used. So this is the rigging design for the offloading, for the lifting. Here we have a rope 90 diameter. It's I think it's a grommet, yeah. 90 diameter and 30.05 meters length, and it's wrapped to the hook. Don't worry about the rigging. It's not actually it was designed by the manufacturer of this gas turbine. So yeah, this is this is the rigging design. So for the hook, for the rigging weight, you can use this rigging design. So yeah, and for your design, you can put on the summary and the attachment like the crane data, or yeah, for the crane data you can put it on the appendices section. So yeah, that's for the capstone project.
Okay. Do you have any question related to your capstone project, everyone? So Nelson, I so Miss Sarma asking about your email address. Maybe you can type in our WhatsApp group for your email address if you don't mind. Okay. And then
Yeah, sure.
Nelson joined with our WhatsApp group, so I just ping him, and then you can see his WhatsApp number.
Sure. I will send my email in the
Yeah,
WhatsApp group.
you can send it through email or through Nelson FDP Consultant email address is okay. So you can send it through email, or you can directly send it through WhatsApp also. That's okay.
Yeah.
So related to this capstone, do you have any question, everyone? Maybe Sarma or Afif, or do you have any question related to your capstone?
And just to add, and it's not limited only for this capstone. You can also ask us through email or WhatsApp if you have any case that you need for second opinion like that, or maybe you have some to be discussed to be added on this program, like for example, oh, you need to add this section or this in your program, the upskilling program, then we could receive a feedback from you. So yeah, so that's not limited on the capstone only. So yeah, back to Miss
Yeah,
Dian.
thank you. If you share some crane details, then that will be good enough. Few crane specifications for this
Yeah,
capstone
sure.
project. Yeah, because we
Sure,
have
I
to.
will send to you.
Yeah, then accordingly, then we will select the cranes from that one.
Yeah.
Thank you.
Just explain me what we should keep in summary and appendix once again, please.
For the appendices, you can put your crane data like the load chart, yeah, like the load chart or the crane's weight like that. And it's okay if you cannot no need to be detailed until the ground bearing pressure, because uh, some of cranes catalog, it's not they not put the cranes weight very detailed in the catalog, so you it will be difficult for us to find all the weight and the COG data for each equipments of the cranes we use. So no need to be very detailed for until the ground bearing pressure. Maybe the ground bearing pressure will be can we calculate outside of this capstone project. The only need to be checked is on the UC only, like that.
So in the capstone project, then what is the exact things what you would like to be get with this one? Because
The UC only,
which one, sir?
the UC, utilization capacity.
Okay, utilization and the capacity based on the crane load chart and the boom length, what
Correct.
you have been choosing, at
Correct,
what radius
correct,
we are going to pick up, and those things only we have to give, right?
correct,
Okay.
correct.
Okay, fine.
Yeah.
Okay, then fine. Okay, but however,
But
because here we cannot able to find any length and nothing, you are not given. No, what is the
yeah,
obstruction? Nothing. It's 6580 and 3000.
yeah, it will be
Minimum
difficult
clearance she
to.
had been given. Yeah, 3000. Okay,
Yeah,
fine.
yeah,
Okay, okay. But
yeah.
if in case, but if we share us some crane load charts, that will be good.
Sure, sure. I will send to you.
Thank you. Thank you. Thank you.
Yeah, Nelson will send it all information through our WhatsApp after this class. So any other question? So Paul already give up thumbs up, so that's mean that he's okay, right, Paul? But if you have any question when when you start doing your capstone, you just text Nelson directly.
Yeah, sure. Thank you.
Yeah. So today I will prepare our recording class from yesterday and also today, and I will send by email to you, and I will attach also feedback form. We hope that you provide us feedback so we can keep improve our class to all of our participants. And then for the next month on May, we have class for fundamental of heavy transport. So for this class, for heavy transport, we will talk about heavy transport. So it will be different with heavy lifting transport. So during heavy transport operation, we will talk fundamental. This is the first class. So we talk about the basic about the basic of heavy transport. So like SPMT or modular conventional trailer. So we talk about start from the basic, like Nelson now talk about something center of gravity and also like calculation, the simple calculation, then operation for the heavy transport. So I think that the class on 16 and 17 of May. So if you wanna join with this class, feel free to see my LinkedIn. I put a link on that and you can find detailed information. But for this class, a little bit early because some of our participants from Australia want to join with this class as well. So I think that we will start on 8 o'clock in the morning Central Time. Let me check a Friday and Saturday, because they asked to start at 8 o'clock in the morning. So it's not 10 o'clock 10 o'clock like now. Start 8 o'clock in the morning. 8 o'clock until 10 o'clock in the morning. So we will have two class also for this. I think that's it. Thank you so much for everyone for our class today. I'm so happy to see all of you today, but I feel sad also because our 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 participant from Australia cannot join with us. What we can do, because there is a global participant is have a different time zone, so I try my best. I will send it recording to them. So Nelson, do you wanna say something before we stop our class?